Good morning, dear students. Today we'll start the next module, module number 3, partial differential equations. In the previous class, we have seen a differential equation. So, just I want to tell here in detail. If you just go back, so differential equation. So differential equation having two parts. One is ordinary differential equation and second one was a partial differential equation. In ordinary differential equation, we have seen the solutions based on in the previous module. For example, we have seen solution of homogeneous differential equation by solving out here complementary function, particular integral and all. But here in partial differential equation, so here the example, for example, so differentiate. So I will write that differentiate z is equal to x square plus y square is there. So differentiation of x square plus y square will be here. So differentiate with respect to x. If I say differentiate with respect to x, so what happens here? So it will become dz by dx is equal to, so 2x plus 2y into dy by dx. But here if I take the same question, z is equal to x square plus y square, so here partial differential equation means we have to go for differentiation with partially, means I'll write differentiate with respect to x partially. Partially means we have to go for the partiality between the two variables. Here z is a function of two variables, so therefore the differentiation of z, so at that time we are going to introduce partial, means it will become a symbol dou. So partial derivative symbol is what here, dou. So dou, this stands for dou, so dou z upon dou x. We are doing partial differentiation of this function z with respect to x of two variable. So with respect to x means only we have to differentiate x. For example, differentiation of x square partially with respect to x is 2x plus, here no x function is there, it is purely y. Y we have to treat as a constant, it is 0. So one more example I can say for the partial derivative. So if z is equal to xy plus y square is there, so differentiate with respect to y partially. So what happens here? So dou z by dou y is equal to, so we no need to apply the product formula, so we have to treat this x as a constant. So differentiation of y with this differentiation of this y with respect to y partially means it is 1, and differentiation of y square partially with respect to y is 2y. So partial derivative means we need minimum two variable so that we can differentiate. In general I can say that if you are differentiating a function, means a given function having two variables x and y, then differentiation of that function with respect to x, if you are doing partially, then we have to treat y as a constant, or if you are differentiating the given function with respect to y partially, then we have to treat x as a constant. And we know that pure constants are 0. If the constant is multiplied with the given this one variable, then we have to keep the constant as it is and we have to differentiate. So by using this concept, we are going to introduce the next module as partial differential equation. So what partial differential equations are going to called here? Equation involving one or more partial derivative of a function of two or more variable is called partial differential equation. Next, here order and degree of the partial differential equation. The order of partial differentiation means, order means what here? First order means first differentiation, second order means second differentiation, Degree means what here? That order raised to whatever, or differential equation raised to any power is there, that is nothing but degree. The order of a partial differential, PDE stand for partial differential equation, is the order of the highest derivative. Means first one time differentiation, or second time differentiation, or third time. So that is nothing but we are going to call it as order, and the degree of the partial differential equation is the degree of highest order, means in that which in that differential equation, in that equation, so which partial derivative having highest order, and that highest order what power is there, that power is going to consider as what here? A degree of the given partial differential equation. Now a partial differential equation is said to be linear if it is of first degree in the linear. When it is called linear, if it is first degree in the dependent, means degree of that partial derivative means of order may be anything, but degree should be 1. So that is going to consider as what here? Partial differential equation of linear differential equation of variable in partial derivatives. Okay, next, if each term of the partial differential equation contains either the dependent variable or one of its partial derivative, the partial differentiation is said to be a homogeneous. So I will tell you with the example here. See here, example, dou z by dou x plus dou z by dou y is equal to 0. So this is, we have two concepts, homogeneous and non-homogeneous here. So both having a first derivative only, so therefore order is 1. So raised to power is what here? 1. So order is 1, degree is 1. So order is 1, degree is 1. So based on that we can say that what, and having only one variables, so we can say that it is homogeneous. But non-homogeneous example, so order is 2, but here with respect to what here? Two different partial derivatives, that is dou x and dou y. So here order is 2, but degree is 1, and I can say that it is non-homogeneous. So such kind of examples are going to consider as what here? Homogeneous and non-homogeneous. And similarly we have two more examples. So we'll see how this partial differential equations are going to work out for the examination, means for the to solve the examples. So we have two kinds of formations. So formation of partial differential equations. One formation is what here? Eliminating the arbitrary constants, and one more concept will come here, eliminating the functions here. So two concepts are there. So constants means maybe any alphabets A, B and all. So I had just taken in generally a given a relation of the form f of x comma y comma z of a comma b is equal to 0. Here z is a function. So z is a function of x and y with a and b are arbitrary constants here. For example, if I say, just see here, if I am considering z is a function of xy, I will give equation number 1. So differentiate 1 with respect to x and y partially. So dou z by dou x is equal to, so z with respect to x means dou z by dou x. So we are going to consider as, we will call it as p. Similarly, if I differentiate 1 partially with respect to y, it will become dou z by dou y, and going to call it as q. You have to remember these results. Now you differentiate this, differentiate with respect to x partially. So again if you differentiate, so this will become dou square z upon dou x square, and it is going to be denoted as r. And here you differentiate with respect to y partially. So this will become dou square z upon dou y square is equal to, and this is going to be denoted as t. Now you differentiate either this or this. If you are considering differentiate 2, I will take differentiate 2 again partially with respect to, here with respect to x, the opposite you take y. So what happens here, dou square z upon dou x, already it is there, dou x into dou y is going to consider as, this is going to consider as what here, s. So maybe dou y by dou x or dou x by dou y, any one case, and this is going to consider as s. So therefore p is nothing but dou z by dou x, q is nothing but dou z by dou y, r is nothing but dou square z upon dou x square, t is nothing but dou square z upon dou y square, and s is nothing but dou square z upon dou x into dou y. So I can say that these are the notations for your partial differential equations to solve the examples. By using this we can eliminate the functions as well as arbitrary constants.